Welcome to Study Loop.
Okay, so this is the free body diagram of the block. So the block is having 4 forces act on it, which is the weight of block, the normal force upon the surface, the friction along the surface. In this case, the friction should be the static friction because the block didn't move. It's about to move, but it haven't moved yet. Okay, and the last force here is the 30-pound force, 30-pound force with the angle theta. And since there's angle theta here, so we can decompose the 30-pound force into xy components. So the x component of the 30-pound force is 30 pounds sine theta, and the y component of the 30-pound force is 30 pounds cosine theta. So therefore, according to Newton's second law, we know net force along the xy direction should be equal to 0 in this case because the block is in equilibrium. Okay, so therefore we have x is equal to 0, which is equal to 30 pounds sine theta minus fs. Therefore, we have fs is equal to 30 pounds sine theta, and fy is equal to 0 as well, which is equal to n minus 30 pound cosine theta plus w. So we have n is equal to 30 pound cosine theta plus w. So we know the static friction can be equal to mu s n. Mu s is the coefficient of static friction, and is the normal force. So we eventually have fs is equal to mu s times 30 pound cosine theta plus w. So then we have mu s times 30 pound cosine theta plus w is equal to 30 pound sine theta. So while we know mu s is equal to 0.25, and let's forget about units at this point, okay? So if we plug in, we'll have 0.25 times 30 cosine theta plus w is equal to 30 sine theta. So therefore, we can put square on each side. We have 0.25 times 30 cosine theta plus w to the power of 2 is equal to 30 sine theta to the power of 2. If we expand it, we'll have 0.0625 times 30 cosine theta plus w to the power of 2 is equal to 90. I'm sorry, not 90, 900 sine square theta, which is 900 times 1 minus cosine square theta. And eventually we'll have such equation here, which is 956.25 cosine square theta plus 3.75 w cosine theta, and then plus 0.0625 w squared minus 900 equals 0. So if we apply the formula, we have the cosine theta is equal to negative 3.75 w plus and minus square root 3.75 w to the power 2 minus 4 times 956.25 times 0.0625 w squared minus 900, and over 2 times 956.25. So therefore, when the w is equal to 75 pounds, if we plug in, we eventually have cosine theta 1 is equal to 0.62. and cosine theta 2 is equal to negative 0.92. And now we can apply the inverse cosine function. So we have the first angle theta 1 here should be equal to cosine to the power of negative 1, and then 0.62 inside the function. And this will give us the angle is equal to 51.7 degree. And the second angle is equal to cosine to the power of negative 1, negative 0.92. And this will give us the angle is about 156.9 degree. So since we know angle theta is less than 90 degree, so therefore the only solution that is plausible in this case should be theta 1, because only theta 1 is less than 90 degree. Okay, so therefore the angle should be equal to theta 1, which is 51.7 degree. Okay, so therefore for the next question, which is when the weight of the block become 100 pounds, we eventually have cosine theta 1 should be equal to 0.37, and the cosine theta 2 is equal to negative 0.77. So therefore the first angle theta 1 here should be equal to inverse cosine function with 0.37. And this will give us the angle is equal to 68.3 degree. And the second angle here, theta 2, is inverse cosine function negative 0.77, and this will give us the angle is equal to 140.4 degree. And remember, the angle theta is less than 90 degree. Okay. So therefore, we have the angle here should be equal to theta 1. Okay. Which is equal to 68.3 degree. And these are the answers for this question.